Okay, so we know how to find the perimeter of a circle now. It's called the circumference, and that's going to help us in finding the perimeter of a sector. So we have a sector here. If we wanted to find the perimeter of this sector, we would need to add up all the side lengths. Okay, that's what perimeter means. So we just need to add up all the sides. We'd need to add this side, which is 3 centimeters, and this side, which is 3 centimeters as well. And we know that because this side length here is just the radius, right? This length goes from the center of the circle all the way to the edge of the circle. And it's the same for this side here. So these sides are both just the radius of the circle. And they're both 3 centimeters in length for this circle. So we know that to find our perimeter, we're going to need to add those two sides. So we're going to need to do 3 plus 3. And then we need to add this curved side length here as well. And this curved side length we call the arc length. And now, if we think back to our previous example, we already know how to find the circumference. And the circumference, if you think about it, that's kind of like the curved side, but for a whole circle. So if it kept going around until we came back to the start here and we had a whole circle, we know how to find that, okay? We know how to find the curved side length for a whole circle. So really, this arc length here, we can think about that as a fraction of the circumference, okay? It's a fraction of a circle here that we've got. So the arc length is just going to be a fraction of that whole circumference. So if we can work out what fraction of a circle we've got, then it's actually going to be quite easy. We're just going to use our formula for circumference. So what fraction of a whole circle are we looking at here? Well, I can see that this is just a quarter of a circle, right? We've got a right angle here, which means that this is a quarter of a circle. So I know that my arc length here, that's going to be a quarter of the circumference. So my arc length, I can write that length there of that side, I can write that as 1/4 of my circumference. And how do I find the circumference of a circle? It's just 2 pi r, or 2 times pi times the radius. And in this case, our radius is 3. So this here, this is just the formula for the circumference of a whole circle. But because we're only looking at part of a circle, we're only looking at a sector, this side length, this curved side length is just going to be a quarter of 2 pi r, or 2 pi 3. So we can work this out on a calculator. 3 plus 3 plus a quarter of 2 pi times 3. They're all just numbers because this is the radius. This 3 is the radius. So if you have the radius, you can work everything out. So 3 plus 1/4 of 2 times pi times 3. And we end up with a perimeter of 10.71. And this side length here, we said that that was just going to be equal to a quarter of 2 pi r, and r was 3 because the radius was 3. So we can work out how to find all of these side lengths. We just add them all together and we get the perimeter. Now, what about if we were looking at a sector that wasn't a quarter? What about if we were looking at a sector that looked like this? And this angle in here is 60 degrees now, not 90 degrees. And we still have our radius. Our radius is still going to be 6 here, we'll say. So they've given us a radius. How are we going to find the perimeter of this sector? We still need to find these two side lengths. And we know that they're both just the radius. So that's 6. This is 6 as well. So our perimeter is going to be 6 plus 6 plus this curved side length here, this arc length. Now, we can't see straight away what fraction this arc length is. So we need another way of determining what fraction of a circle we're looking at. And another way to do that is by looking at this angle here. So if our angle is 60 degrees, and we know that the angle for a full circle, a full revolution, is 360 degrees, then we know that we're looking at the fraction 60 out of 360. We're looking at the fraction 60 out of 360 of the full circle. So our arc length here is going to be 60 out of 360 of the circumference. So again, we're using the formula for circumference, which is 2 pi r, but in this case, our radius is 6. So now we have our formula. It's really quite simple. In this case, we could see that we were looking at a quarter of a circle, so we knew straight away. But in this case, we couldn't see straight away, so we just had to use the angle. And we said, well, if we're looking at only 60 degrees here of the circle, we know that a full circle is 360 degrees. We know our fraction is 60 over 360. So if you know the angle inside, then you can easily work out the arc length as long as you've got the radius as well. So we can do this on a calculator. 6 plus 6 plus 60 over 360 of our circumference, 2 times pi times 6, is 18.28. Okay, so this time let's try and write the formula for perimeter of a sector in more general terms, okay? So they haven't given us any numbers, any numerical values to put in there, but we're going to write it where r is the radius and theta is the angle inside the sector here. So for our formulas that we had up here, we were using the specific radius, so we used 6, and the specific angle, or the specific fraction here. But for this one, we're gonna try and generalize it so we get a rule that we can use for any sector. All right, so the perimeter, we just need to add up all the side lengths. So we need to add this side length plus this side length, and we know that these are both just the radius. They go from the center of the circle out to the edge of the circle. We know the radius is r, so we can write r plus r. Another way we can write that is just 2r. We're going to have 2 lots of r. Plus, now we need to find the length of this curved side, this arc length. And the way we do that is we need to find the fraction of the circle first. So we need to use this angle in here. And we know that if we've got this angle, it has to be out of the full angle for a circle, which is 360. So we've got theta here out of a total of 360 degrees. Same here, we've got 60 degrees out of a total of 360 degrees. So whatever this angle is, we have to put it out of 360 or over 360. So theta over 360, that's the fraction, and we want to know the fraction of the circumference, okay? We need to find the fraction of the circumference in order to find this curved side here. Because remember, the circumference is kind of like the curved side for the full circle. So we're just finding a fraction of that. So a fraction of the circumference. And the formula for circumference is 2 pi r, where r is the radius. So here we have our general formula for the perimeter of a sector. So whatever the radius is, we plug that number in here. That's the radius. And whatever the angle is in the middle of the sector here, we plug that in there. So if it's 75 degrees, we put 75 here. If it's 2 degrees, we put 2 there. So we need to know the angle inside the sector, and we need to know the radius length as well. And then we can work out the perimeter of the sector. All right, so I've written the perimeter of a sector formula here. You can memorize the formula, or you can sort of use common sense to come up with the formula yourself. You can say, well, I know that the perimeter is just going to be all of the side lengths added up, the sum of all these side lengths. So I know I need to add the radius plus the radius, or 2 lots of the radius, and that's where that 2r comes from. And then I need to add this arc length here. So I need to somehow find the length of this curved side. And I know that's just going to be a fraction of the circumference. So the fraction is going to be this angle on the inside of the sector, which is that angle there, out of 360 times the formula for circumference, which is 2 pi r, and we should already be memorizing that from our previous example. So you can use common sense to work it out, or you can memorize this formula here. Either one is fine. So let's move to example 1. Find the exact perimeter of this shape. Let's write down our formula. Perimeter is going to be our 2 straight sides there, which are the radius, so 2 times the radius, plus our curved length, which is going to be the fraction, and it's going to be the angle inside the sector out of 360. That gives us our fraction of a whole circle, times the circumference, because we just want a fraction of the circumference. So 2 pi r. That's our formula. Now we know our radius is 2, so we can plug that in. 2 times 2 plus, now what's theta? What's our angle inside the sector here? Well, you can't really see it, but this was a right angle here. And if we know that a full circle is 360 degrees, what's the angle over here going to be? It's just going to be 360 minus 90. So it's just going to be 270 on the inside here. This angle is 270 degrees. So our theta is 270. And we're making a fraction here. So 270 over 360. That's our fraction of a full circle that we've got. We've got 270 out of 360. If we actually do that on a calculator, 270 over 360, you can see that it's 3/4, and that makes sense because it looks like we've got 3/4 of a circle here. So we're going to have 3/4 of the circumference here. That's what our arc length will be, 3/4 of the circumference, which is 2 pi, and our r, our radius, was 2. So we have to be careful now because the question says find the exact perimeter of this shape. Now, an exact perimeter means that we don't want to be rounding off, okay? We want our solution to be exact, so we don't want to end up with a really long decimal as our answer. Now, we have been getting really long decimals for our other answers, and that's because of this guy here. If we look at pi, pi is this number, 3.14159, and it keeps going on. So if we use pi in our calculations, we're not going to be able to get an exact answer. So we're going to leave pi just as this pi symbol, okay? It's going to represent the number pi, but we're not going to round it off at all. So we're not going to put pi into our calculations. We're going to treat pi as though it's a pronumeral in an equation. We're just going to leave it. We're not going to operate on it at all. So we can operate on everything else. 2 times 2, that's 4. Plus, well, we can simplify that to 3/4. We know it's 3/4 of 2 times pi times 2. Well, that's going to be 4 pi. 2 pi times 2 is just going to be 4 pi. So we can kind of simplify this equation a little bit. We can say now, let's look at order of operations. How can we simplify this? 3/4 of 4 pi. Well, if these are just fractions, it's kind of like we're just saying 4 divided by 4. We can cancel those out, and we're just left with 3 times pi. So it's just going to be 4 plus 3 times pi. And that's an exact solution for the perimeter. If they said to round it off to a decimal place, then we can just put that into the calculator, 4 plus 3 times pi, and we'll end up with a number. But if they ask for an exact solution, they don't want you to work out this pi. They don't want you to evaluate pi. They want you to leave it as pi and kind of treat it like it was an x in an equation, and leave it in its pi form. So you can just collect like terms around it, and you can say, oh, 2 pi times 2 is 4 pi, but don't actually evaluate this on the calculator.